Researchers in the UK have started a new study which aims to understand how the new coronavirus is affecting people in different ways. They will sequence the genome of 20,000 patients who've been in intensive care with COVID-19 and 15,000 people who experience milder symptoms. The findings will then help shape treatments for the current outbreak and potentially help avoid further waves of COVID-19. Well, Professor Mark Caulfield is the Chief Scientist at Genomics England and joins us now from London. Thank you very much for taking the time. So my understanding is that you're trying to help identify some of the factors about who might become severely ill if they contract COVID-19. So what's the aim of the study? Is that right? And how are you going to carry it out?
Yes, so the aim of this study, which is led by Genomics England and the University of Edinburgh, is to ask a really simple question, which is why do some of us become very severely ill and require support with breathing machines, and others have a very mild or even asymptomatic course? And by doing that and comparing the two groups, we may be able to identify factors that get us to new therapies, probably medicines that already exist that we can bring forward into trial to support people when they're severely ill, or even help to prevent people becoming as ill as some people have sadly become across Europe.
And what kind of theories do you have that you're looking to explore about what those differences might be? Is it in our genetic makeup? What is it about one individual from another that means one could be very seriously ill and the other have no symptoms?
So you and I have a genome of 3 billion letters. It's your and my blueprint for life. But in that genome, every few letters, there's a variation. For some people, that variation may change nothing. It may be harmful. For others, if they come across an insult like coronavirus, this may lead to them becoming severely ill, possibly due to their own immunity and their response to the infection and how they react to it, but also due to how they admit the virus inside their body. And these factors can be unraveled by genetics. We know that all of us possess rare and common changes in our DNA that can affect our immune status.
What are you hoping that you'll be able to do when you get the results of this? Because we know that some people are in different risk factors, so people who are pregnant, people who are maybe in a different age group. Might this research help better define who should be in those high-risk categories?
Yes. So another feature of this is to look for biomarkers that might allow us to more effectively define who is at risk of a severe outcome. So a conceivable possibility would be, if we succeed, that people may be able to discern who should isolate earlier, who should stay away. The other benefit potentially is by identifying people who are at very low risk, and if they've already been affected, they could return to work. So in terms of kickstarting the European economy, we need a range of measures that allow us to safely enable our workforce and citizens to return to their workplace and to bring some normality back to day-to-day life.
Mark Caulfield, thank you very much for speaking to us from Genomics England about the status of your research.